Hi everyone, it's Mr. Patron, and in this video we're going to go through our notes about the atomic structure. So we're just continuing the lesson. You guys have just worked through the build an atom FET simulation, and we've discussed some major points from that. So now you guys are just going to work through this video and get down some notes about the atomic structure and reading the periodic table. So I'm just going to share my screen. So the student copy of these notes has been posted, so you should have seen them already. And I'm just going to basically fill in the blanks on your own. Feel free to pause the video and take care of whatever you need to take care of to take these notes. Of course, you don't have to get down every single word. You can paraphrase whatever's in here, and these are your notes. So no one is going to check them. These are just for you. Okay, so we're going to get started with this. So today we are talking about the current model of the atom. And basically what we know about the atom as of now is that there are three main subatomic particles. So the word subatomic, sub, this prefix means below. So below the atom's level within the atom, we have these three particles. We have a proton, the neutron, and the electron. So the proton has a positive charge. It has a mass that is defined as 1 atomic mass unit, or AMU. You may also see the word Dalton as a mass unit, but typically you'll see AMU. And the proton is located in the nucleus, so within the center of the atom. So you may remember a nucleus from Living Environment is like the center of the cell that contains a lot of the genetic information. The nucleus of the atom contains a lot of important information as well. Also in the nucleus, we have neutrons. The neutrons are particles that have no charge, so no charge or a zero charge. And they also contain a mass of 1 atomic mass unit. And once again, these are found in the nucleus. So if we look at this picture, we have our protons that are marked in blue, the neutrons marked in red, and they are within this smaller middle piece known as the nucleus. Outside of the nucleus, we have these negatively charged particles known as electrons. So once again, they have a negative charge, so -1. So each electron has a -1 charge, and much like each proton has a +1 charge. Electrons, at least in chemistry, we say they do not contain a mass. If you go on to physics, you will just learn that electrons do in fact have some mass, but chemists think of it as essentially zero. So the electrons do not affect the mass of the atom. And they are not found in the nucleus, but they are found in orbitals surrounding the nucleus. So we see these on this specific model of the atom, kind of like a Jimmy Neutron style. You may remember that TV show. So the electrons flow in this orbital. So in this weird little oval shape, they're kind of flying around the nucleus of the atom. And like if it looks like here, it looks like we have 3 electrons floating around here. So once again, the model of the atom currently states that we have 3 subatomic particles: the proton, the neutron, and the electron. Now, we're going to also take a look at the periodic table. So the periodic table, what it is, and honestly, this is a lot of notes. So once again, you don't have to write down every single thing there. Summarize it, write down whatever you need to. So the periodic table is an organized list, essentially, an organized table that hosts all 118 currently known elements. So literally, if you counted every little box here, you would have 118 boxes. Each element has a name and a symbol. So the symbol is what we see on the periodic table, and of course we do that to keep it smaller. Like if I have all the names of all these elements out here, it get a little crazy. So the symbols typically consist of a capital letter, and sometimes they contain a lowercase letter as well. So for example, oxygen. Oops, sorry. So like oxygen is an element, and it has the symbol O. Another example would be copper. copper is another element. Copper is right here, and it has a symbol Cu. Once again, the first letter is capital here, and the second is lowercase. Now, on your reference tables, within your reference table, the middle pages contain the periodic table, and then the following 2 pages from that contain a table called Table S, selected properties of the elements. Now, this Table S allows you to match the element symbol to its name, and it also has some other properties that we will look into. So we are going to look at some other components of the periodic table in the next few slides, but I wanted to also point out this little key here that's at the top of your copy of the periodic table. So we see here we have a symbol, and then a few other things that we are going to get into today. So atomic mass, atomic number, and the electron configuration. So we are going to get into that just in a bit. Okay, so now in the Edpuzzle video, you're going to answer these questions, but I would like you to open up your reference tables to the periodic table. Once again, that's on page 9, and then Table S is the following 2 pages, pages 10 and 11, and answer these questions based on it. Once after you answer them, we're going to go through them together. Okay, so you've gone to your periodic table, and the questions ask you to find the element with the symbol Li. So you should be able to see that Li is in the top left of the periodic table. You might also be able to describe that it's in the first column and the second row. So columns are vertical, rows are horizontal. What number is located directly under the symbol, so the bolded letter? So we should see that that number is 3. And we'll get into what this number represents along with the other numbers represented here. What numbers are located directly under that? You should have seen a 2-1. What number is found in the top left? So that is, sorry, I lost my pen. That was 6.941. Wanted you to identify the name of the element using Table S. So you should be able to see that that is lithium. And then the melting point of lithium on Table S is 454 Kelvin. So don't take another look if you got any of these wrong, or if you need to take, or you need to double check your answers here. Okay. So now we're going to talk about some of the components of the periodic table and how they relate to the atom. So the atomic number is this number that we saw that was directly under the element symbol, that bolded one. So for lithium, it was 3. Now, as we know, each element is made up of its own types of atoms, and these atoms all have their own specific properties. So an atom's identity is determined by the number of protons that are found in its nucleus. So this is known as the atomic number. And all elements are organized by this atomic number on the periodic table. So we go from 1 to 118, and they go in order by the number of protons. Now, what this means is that that every atom of that element is going to have that number of protons in its nucleus. For example, all oxygen atoms have 8 protons in their nucleus. So if I asked you how many protons were in the nucleus of a certain atom, you would just look on the periodic table, find that atom, and find that element, and look for its atomic number. That will tell you how many protons are in the nucleus. So just to reiterate, the number of protons is equal to the element's atomic number. And this number gives the element certain properties. The next thing we're going to look at is the atomic mass. So atoms, we have defined previously, are the smallest unit of matter. So because they are a piece of matter, they must have mass. So the mass of the atom is determined solely by what is in its nucleus. And you probably saw that in the PhET simulation we went through earlier. So those subatomic particles, the protons and neutrons, those added up give you the atomic mass. So as we remember, the protons and the neutrons each have a mass of 1 AMU. So if I counted up the number of protons and number of neutrons in an atom's nucleus, that would tell me essentially how much this atom weighs. Now we can see this on the periodic table. Like I put this key here again. So on the top left corner, you can find the atomic mass of the element. Now, the atomic mass is not a whole number, and we're going to get into that in the next couple of weeks, why that's the case. But for now, we're going to round this number here. So essentially, we're going to say this element is carbon. Its mass is 12. So carbon has a mass of 12. Now, one other thing we can get from this is how many neutrons are in the atom. So hopefully you recall from the previous slide that the number of protons is determined by the element's atomic number. The number of neutrons we can get by determining what's left over from the mass. So I like to use this little equation here where mass is equal to protons plus neutrons. Just going to section this off. So if I know the mass of carbon is 12, and I know that it has 6 protons because the atomic number is 6. To determine the number of neutrons, I would just solve for n. So in this case, an atom of carbon is going to have 6 neutrons. So from the mass, we can determine how many neutrons we have, and because that does correlate to the mass number subtracted from the atomic number. Sorry, the atomic number subtracted from the mass number. Okay. So I want you guys to try these out as well. The Edpuzzle video is going to pause and have you work through each of these. And then we'll check back in a minute. Okay. So I want you to find the following element on the periodic table, phosphorus. So if you are struggling to find particular elements and their symbols, what you want to pretty much try to do is find the letter that it starts with and try to match that. So the symbol for phosphorus is P. Now, of course, not every element has the same symbol as its first or second letters. That's because a lot of elements are actually named after Greek or Latin names. So those we will start to get used to remembering those, but you may just have to dig through table S to find these. But the symbol for phosphorus is P. That is phosphorus's atomic number. So once again, you find on the periodic table, you find the P, and then you would see that right underneath that P, the bolded number is 15. Now, how many protons does an atom of phosphorus have? That directly relates to its atomic number. So it has 15 protons. Now, if you look at that top left corner, you will see the atomic mass. And it asks us to round to the nearest whole number. So the mass that's given on the periodic table is 30.97376, which we're going to round to 31 atomic mass units. Now, how many neutrons does a typical atom of, this should be phosphorus, not oxygen, phosphorus have? And explain how we can tell. So we're going to use our little equation, and this can essentially be our explanation. So mass equals protons plus neutrons. The mass that we had was 31, which equals Rp, protons is 15, plus N. We subtract 15 from both sides, like you would in math class. And you get that N, the number of neutrons, equals 16 neutrons. Okay, if you got any of these incorrect, make sure to double check and see where you went wrong. Now we're going to talk about the last subatomic particle. So that is the electron. Now, as we mentioned earlier, electrons are not found in the nucleus, but they are found in orbitals that are surrounding the nucleus. So they are moving around, not a good circle, moving around the nucleus like so. You can tell I'm not great at drawing circles, especially on a little tablet here. I'm just going to erase that. So the orbitals, we also typically refer to them as energy levels or rings. So let's keep that in mind. And we use these models that are known as Bohr models. So we will get into where that name comes from. Sketch out the atom structure. Now, in a neutral atom, so one that has zero charge, the number of electrons is equal to the number of protons. Because once again, we know a proton is a positively charged particle, where electrons are negatively charged. So if I have 10 protons, I have 10 positive charges. And if I have 10 electrons, I have 10 negative charges. Those charges cancel out, like as you know from your math class. Positive 10 plus negative 10 is equal to 0. We are going to get into how atoms can have a charge later on in the unit. Once again, a neutral atom has the same number of protons as electrons. And for the time being, every atom we study is going to be neutrally charged. Now, the electrons are organized in these specific patterns that are known as the atom's electron configuration. And this is found underneath the atomic number on the periodic table box. So it's a series of numbers that has a dash or 2 or 3. Now, if you look at magnesium, it should have an electron configuration of 2-82. So if you look at the periodic table, you'll see magnesium, its atomic number is 12, and then directly under that, you should see 2-8-2. So what do these numbers mean? This means that each energy level has a designated number of electrons. So, and it starts from the ones that are closest to the nucleus. So the first energy level has 2 electrons. The second energy level has 8. 1, 2, 3, 4, 5, 6, 7, 8. And the third energy level, or the final one in this case, has 2. Now, if we count this up, it'll also give us 12, which matches correctly to the number of protons we have. So we can tell that this is a neutrally charged magnesium atom. Okay, so just to summarize here, the electrons are found in these orbitals that surround the nucleus, and then each energy ring or each orbital has a certain number of electrons found within it. That is known as the electron configuration of the atom. Now, one more thing about electrons is that they do contain energy. So, I'm sorry, each orbital of the atom contains a specific amount of energy that keeps the electrons in their path. This energy is known as a quanta. So quanta, like quantitative, it's an amount of energy. So it's a numerical amount of energy. Now, these electrons are allowed to move between the energy levels. However, doing so requires they either gain energy, so it takes them in, or release some. We'll get into that later. In terms of energy, the ones that are furthest away from the nucleus, so in this case, the ones on this third ring, have the most energy. These are known as valence electrons. So the valence electrons are in the last ring of the atom. They have the most energy, and they're the ones that are responsible for the specific chemical properties of the elements. So the fact that magnesium has these 2 valence electrons gives gives it its own properties. Now, just to reiterate, magnesium has 2 valence electrons, and they reside in the 3rd energy level, or the final energy level. The most valence electrons an atom can have is 8, and that is known as a stable valence shell. So that is the one with the least energy within it. So, and then we can tell this by looking at the Bohr model. So we see the orbital that is the furthest from the nucleus has these 2 valence electrons, or we can look at the periodic table and determine that being magnesium has the configuration of 2, 8, 2. This last number indicates how many valence electrons we have. Okay. So now just one last check for your understanding. So this is the image, one of the images that was in your Do Now from the lesson. So I want you to take a look at this and answer these 4 questions here. And then we will check back in a minute. Okay, so you answer these questions. So how many electrons does this element have? So what we're going to do, we're just going to count all the electrons, all the dots that are surrounding the nucleus here. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 electrons. 13 electrons. Just to note, this symbol, E with a negative, is known as the electron symbol. So if you see that pop up, that's just what that means. How many valence electrons does the element have? So remember, valence electrons are the ones that are in the outer shell in the last orbital, last energy level. So we're just going to look at those. I'm just erasing my initial count. So we have on this last ring 1, 2, and 3. So 3 valence electrons. What is the electron configuration of this atom? Okay, so we're starting with the electrons on the inside ring and then going out. So the first ring, ring 1, has 1, 2 electrons. The second ring has 2, 4, 6, 8 electrons. And then the final ring, as we mentioned, has 3. Now you'll notice that the electrons are paired up in this second ring. Electrons do actually, when they are surrounding the orbital, when they are going around the nucleus in their orbitals, they do pair up with another electron. So you will typically see them sketched out like that. If you want to space them out more and not have them paired up, that's totally fine. It's however you like to sketch it. Okay. And now, what is the name of this element? So here we kind of have to flip back to our periodic table and make the connection that because we have 13 electrons, and as we mentioned, all of our atoms for now are going to be positively charged, neutrally charged, we must also have 13 protons. So the element that has 13 protons has the atomic number of 13, which is symbol Al, which is aluminum. So once again, I was able to derive that the fact that we have 13 electrons must mean we should have 13 protons in our nucleus. The element that has atomic number 13 is aluminum. Okay, if you got any of these wrong, go back and check your answers over, see what mistakes you may have made. And I'm just going to clear this, and then we are just going to wrap up. So for the rest of the period, I want you to complete in your notes this chart like so. So you have 3 elements here. The first one is done for you. So you have your element name, the symbol, the atomic number, the atomic mass rounded to the nearest whole, number of protons, electrons, I'm sorry, protons, neutrons, and electrons, and then the Bohr model, which is the model with the rings that we just went through. So do the same for nitrogen and sodium. So just to get some extra practice in with recognizing the symbols and the numbers of protons, neutrons, and electrons. Along with that, just a couple of reminders. There is a Unit 1 survey that you're going to complete by 8 p.m. tonight, so please do that. Your follow-up activity for tomorrow is some extra practice with atomic structure, so it'll be very similar to this independent practice here. And then a periodic table scavenger hunt, so it's going to allow you to get more familiar with using the periodic table. Along with that, there is an extended assignment that will be due next Monday, or well, it will be due, I'm sorry, it is going to depend on whichever class you are, I'm sorry. So it will be due the day before your next class. So it will be posted on Classroom. And that is the Atomic Theory Timeline Reading Assignment. So you're going to read about how the structure of the atom has changed over the course of the year studying chemistry. Okay. If you have any questions, feel free to send an email and have a great rest of the day. Bye.